let's give the graph of a polynomial here. We're going to find the zeros, if any, and give the multiplicity of each. Well, there's definitely zeros. We've got one at -4. Let me bring this down here. I'm going to have my zeros and my multiplicity. X equals -3. X equals -1. X equals 3. And X equals 4. All right. None of them are bouncing. No, there's none. They're all crossing through. And none of them look really lazy. Like the cubics. They all look pretty linear. So I would say their multiplicities are 1. They're definitely odds, but I'm going to say they're 1. All right. So that means, based on my guess right now, 1, 2, 3, 4, 5, I'm guessing the degree is at least 5. All right. There's another thing I need to check for that too. So I found that, did that. Find the y-intercept. Y-intercept is 0, -1. Only reason I do this is so you use this point to find your a. It's just the easiest way to do it. Find the end behavior. Okay, well, I don't need to do anything exciting for that. As x approaches -infinity, my f of x, the y value, is approaching positive infinity. As x approaches positive infinity, it's heading south, so f of x is heading to -infinity. All right, then we've got the least possible degrees, and I'm going to use my max turns for my other check for that. For my max turns is equal to n minus 1, because I've got 1, 2, 3, 4 turns, and my n is my degree. So 4 plus 1 is 5. So our least possible degree is 5. We've got two different things that show that. Write the equation for this polynomial. Okay, so f of x, don't forget your a. Take each of these zeros, and I'm going to show you what I do for those of you who struggle with this. Take x equals -4 and set it equal to 0. To do that, you just add 4 to both sides, and you get x plus 4 is equal to 0. So there's x plus 4. The next one, x equals -3. Set it equal to 0. Add 3 to both sides. X plus 3 is equal to 0. So there's x plus 3. Next one, x equals -1. Set it equal to 0. Add 1 to both sides. X plus 1 is equal to 0. And then lastly, last two, you would take x equals 3. Subtract 3 from both sides. X minus 3 is equal to 0. And then do the same thing with 4. X equals 4, so subtract 4 from both sides, and you get x minus 4 is equal to 0. All right, we're not done. We need to use our y-intercept. You can use any point, honestly, from this guy, but I like the y-intercept. Any of the zeros probably wouldn't be too bad either. Y-intercept is 0, -1. So -1 for my y, and all of my x's become 0. So this is 4, 3, 1, -3, and -4. Right? 12 times 12, so that's -144. Divide both sides by -144. And a is equal to 1 over 144. So the equation is f of x, 1 over 144 times, and I'm just going to do not multiply these, just x plus 4, x plus 3. Remember, if they have multiplicities other than 1, you would want to put those in the exponents, but these do not. Oh, minus 4. All right. There is my answer. And this is x minus 4 for this one. Do not forget your f of x, and don't forget your a. All right, find the zeros of the polynomial function. Okay, well, I've got 4 terms, so I always make sure they're highest to lowest in their exponents. and then I look at the first two terms to see what I can factor out. And I can factor out an x squared. So 0 equals x squared, because we're finding our zeros. This leaves me with 2x minus 1. To make this one look like 2x minus 1, I would need to factor out a negative 2. No, a negative 4. There we go. Even better. Negative 4. All right, so interesting. Because negative 4 times 2 is negative 8. Negative 4 times negative 1 is positive 4. So let's go ahead and factor out 2x minus 1 from these two terms. And when we do that, we're left with x squared minus 4. Take each of these terms and set them equal to 0, or you could see that this is the difference of two squares, and you could factor it into two parentheses as well. So if you did that, you'd have 2x minus 1, x minus 2, x plus 2. You would set each of these equal to 0. And solve for x. So x is equal to 1/2, x is equal to 2, and x is equal to negative 2. I did that relatively fast because I want to come over here and show you if instead you took just these and set them equal to 0. Add 1 to both sides. Divide both sides by 2. X is 1/2. There's one of them. We should have 3. If you didn't see this was the difference of two squares and you wanted to solve it with the square root property, you add 4 to both sides. And then take the square root of both sides. Remember, this side is plus or minus, so x is equal to plus or minus 2. There's your 3 answers. Let's do one more. Oh my gosh, my dog thinks she's dying. Find our zeros, so 0 is equal to, I can factor out an x squared. Leaves me with x to the 4th minus 2x squared minus 3. Let's see if I can keep factoring this. Looks like it. 3 and 1. Negative in the middle. Positive. Yeah. Okay, let's set each of these equal to 0. Square root property is the only one we can do. This sum of two squares cannot be factored. It is prime. Please don't do that. Please just set it equal to 0 and solve square root property. So this is x equals 0. This is multiplicity of 2, so this is a double 0 as far as this type. Add 3 to both sides. X squared is equal to 3. Take the square root of both sides, plus or minus on the right. X is plus or minus the square root of 3. There's 2 more zeros. Subtract 1 from both sides. X squared is equal to negative 1. Square root of both sides, plus or minus. You have to understand that the square root of negative 1 is I. And there's 2 more imaginary zeros. All right, I'm going to save this next one and do it on its own.